then we will see the our next class. Subject is analog electronics. In this class we will discuss about the classification of feedback amplifier. So we can do the classification in amplifier. First, there are 4 type of classifications of feedback amplifier. First, voltage series. One is a voltage series. This is the voltage series. This next is a voltage. This is the voltage series. Here means voltage series means this voltage. This is second is voltage shunt feedback amplifier. Third is a current shunt feedback amplifier. Fourth is a current series feedback amplifier. So this is in a voltage series amplifier. This is the diagram of voltage series amplifier. Here in the voltage series amplifier, you can see here. This is the voltage is mixing in series. The voltage is mixing on series voltage. Here voltage is mixing. Voltage is mixing on series. Mixing on series. And here this is the input terminal. Voltage is mixing at the input terminal. This is the input terminal. This is the output terminal. Voltage at the output terminal voltage is shunting. You can see the at output terminal voltage is shunting. Here shunting of voltage is done. Shunting of means this is the voltage. This is here node application is done. Here input में voltage series mixing and at output terminal voltage is sampling is here. At output terminal voltage is sampling at the output terminal. Voltage is sampling at output terminal. Voltage is sampling. Voltage is sampling it output terminal here. So that's a first how we'll write it. This we take at output terminal, which is so voltage at output terminal we can write voltage. Then this input terminal mixing is done on the series. This mixing is done on the series. So that's why we are writing here series is there. So that's a voltage shunt feedback. In voltage shunt, the input current increased by 1 plus beta into beta factor times, and output current is reduced into a R0 divided by 1 plus A into beta time. So this is the against voltage. Here we can see this is the voltage series and this is the voltage shunt. How will write this in a voltage level? This is the means here the voltage is shunting. Here voltage की sampling हो रही, sampling of voltage. Input terminal पर sampling of voltages. Sampling of voltage. Here at output terminal also sampling of voltages. Here sampling of voltages. So first how will write? We take this value from here and we should write here. This is the voltage. The sampling means shunting. Is here at input terminal we see this is sampling. Sampling is nothing but here sampling means this is the shunting. At input terminal this series means this is series mixing. This is here mixing. Mixing means series. Mixing is always done on the series. Mixing is always, and sampling is done on the sampling means shunting. So we will see here this is the output. This is the at output terms. This output term just like here output term voltage here output, and this term is take from the input. And if the input for sampling is there, that means shunting. If here input for mixing is there, that means series. That means series. So how we can write this? This is the again current shunt amplifiers. So how we are writing this? This is the diagram. This is the gain of amplifier. This is the feedback factor beta. This is the called gain of amplifier. A is a gain of amplifier. This is the feedback factor. 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 Feedback factor. So this is here input impedance is increased here. Input impedance is also here. Input impedance is decreased into decreased. We can write the input impedance. This is the input impedance. Input impedance Ri is decreased. Input impedance is decreased. Here output impedance is increased 1 plus beta time. In previously we have seen this input impedance is this input impedance. This is the increased. The input impedance increased and output impedance was the decreased. We can write this for analysis. Then we can see this. So how will we see? We can see this term decided by this term here mixing is here. You can see the 8 output terminal is a current. So we can write this here as direct as a current here. Again we can see it input terminal is a voltage, but voltage sampling. It input terminal voltage is sampled. Because of sampling means this is a node is made. So this is the because sampling, because node is made here. Node is made, and that means this is the shunting. This is the shunting. Shunting, that means this is the shunting. Shunting, that means this is the shunting. Because of this, so this is how will decide the name of this feedback amplifier. And this next is a current series. How it this term is decided by this term is decided by it this term. This is because of current. Here current is there, then here it input on mixing is there, because here series is formed. That's mixing means, you can see mixing means what? Mixing of what? This mixing is done. If the mixing is done, then mixing means mixing is done on series. Mixing is done on series. So then we can write this here. We can write here in series this. Here input impedance is increased. Input impedance increased. Here output impedance is decreased. Sorry, output impedance. Sorry, we have wrote this. Output impedance is also increased. Here output impedance is also increased. Output impedance is also increased. Both will be increased. So this is the feedback effect. We can see the effect of feedback amplifier in voltage and resistance. Here input resistance ka input impedance is decreased 1 plus beta times decreased out in the voltage shunt. Effect on input resistance. So input impedance, this is the input resistance is decreased. Input impedance is decreased. Input impedance, output impedance also both. This is the voltage shunt impedance increase. Current shunt impedance also decreases. Voltage series input impedance is increased. Voltage series impedance increased. Current series impedance is increased. Means what we have said, input impedance, if this we can take the series, then input impedance will increase. In shunt, input impedance will decrease. We can decide it for shunt, input impedance is decreased. Effect of output. Output means voltage shunting. At voltage level, voltage shunting means shunt means output impedance. Shunt means output impedance here decrease. Shunt out here current shunt output impedance increased. Here output impedance decrease. Similarly, voltage series feedback. We can voltage series output impedance decrease. Input impedance again this is the increase. So this is the effect. So how we can summarize all things what we have studied? Currents. This is the current voltage series voltage shunt feedback amplifier. Input impedance is what? Input impedance is decreased here. This input impedance is decreased here. the output impedance increased here. Current shunt feedback amplifier, current shunt feedback input impedances decreased, output impedance is increased. Voltage series feedback amplifier, voltage series feedback amplifier output impedance is input impedance increase, output impedance decrease. So all these things we can do the analysis. Current shunt feedback amplifier equivalent circuit, you can see voltage shunt using transistors. This is the equivalent amplifier. So this is the current shunt equivalent circuit. So for today it is sufficient. Next class we will discuss about the